Okay, and we are live. So, welcome everyone, and welcome to this Agent Intelligence. So, we are exploring everything around the future of AI agent in Web3. We're speaking with thought leaders in the space around kind of like AI agent infrastructure, provider, and anything around agents and more. So, I'm Francesco. For the people that doesn't know me, I'm part of the developer relation team at MetaMask and also contributing to MotorDAO. I'm super excited, and today we're deep diving into technology and the vision behind Icadot. And super excited because you guys rebranded. I remember meeting some of your colleagues back in the days. And I just want to say, David, it's a pleasure to have you here. And you want to quickly introduce yourself.
Sure. So I'm David. I'm one of the co-founders of ICA, um, and we've been working for quite a few years on some novel cryptography, and we'll talk soon about how it relates to AI agents as well and what it unlocks. But our background is mostly cybersecurity, cryptography, AI, deep tech. We started. This is our first project in Web3, which we started almost 3 years ago now, and we're very excited to go live with mainnet very, very soon.
I mean, this is super exciting. I think the reason why kind of like I met you guys for the first time that all the team was a super brain, PhD from everywhere. Like I remember like the level also like on the research side was actually like super novel, and I was quite struck about the innovation, and I'm definitely very excited to see what you guys are cooking around the agent side. And obviously like congrats on pushing to mainnet. That's always like a big milestone. Okay, and just quick housekeeping for anybody has any question, feel free to also ask in the chat here. I'm just posting here right now. Welcome, and I will bring it up to ask David or myself. And I think that's a little bit it. Let's get it started. So, David, like you kind of introduce yourself a little bit. You want to quickly give a background how kind of like everything kind of started, and then we can deep dive on the relationship on the agent side.
Sure. So, my co-founders and I, as I said, we all come from a background of cybersecurity and cryptography and deep tech and AI. And when we all wanted to work in Web3, and we wanted to solve a big problem, and we looked for a while to find like a big problem that actually required new tech in order to solve. And we realized that one of the biggest problems is around interoperability, and specifically what we call zero trust interoperability. So being able to operate across multiple networks without removing the zero trust security guarantees. So when you're on a specific blockchain, you know that you don't need to trust anyone. You know, you don't even need to trust the validators. You don't need to trust the miners, right? You have these zero trust guarantees. But the moment you want to operate across multiple chains, you lose those zero trust guarantees. You now need to trust a bridge. You now need to trust a committee. Your assets are deposited somewhere. Sometimes you get a wrapped assets instead of your real asset, right? There are all these extra layers of trust, and that really breaks something very fundamental in blockchain technology. So we realized that in order to solve that, we'll need to create new cryptography. And I'm this was kind of our challenge for the past 2 years. Sorry, the past 3 years. The first 2 years were mainly just research, cryptography research, and
Long
then
time.
we did
Yeah.
implementation. And this also relates to AI agents, because this is one of the biggest challenges that AI agents have, is how to operate across different blockchains, and what are the security guarantees, what are the trust assumptions that you have when you use an AI agent to operate on different blockchains. So happy to dig into that.
Nice. Nice. Yeah, no, that actually sounds good. I definitely would love a little bit to understand also, what kind of like the not just the key trends, but kind of like what was the problem that when you see kind of like all this agent wave developing, like do you said, okay, this is something that we really need to solve because either there is some kind of like pain points, and we is something that with your technology you can actually solve it. So like the question here is really like what problem were you kind of initially trying to solve with like in relationship to seeing this wave of agent getting
Yeah.
built.
So I have to say, when we started was 3 years ago. Obviously, AI agents were
Hmm.
very, very far from where they are today.
Yeah, of
So the
course.
problem we are solving is a much more general problem, and also the infrastructure we created is much more general. I do think that AI
Mhm,
agent is going to be one of the major use cases that our infrastructure is used for, just because it solves a very fundamental problem. But maybe we can start about the problem itself, talking about the problem.
mhm, mhm,
So when you want to have someone operate on your behalf, let's say I'm an amazing trader, right? I'm not, by the way, never giving me your money. But let's say I'm an amazing trader and you really want me to trade for you. So you have a few options, right? One option is you need to trust me and give me your assets, right? That's one option. And if you trust me, that's great. But in most scenarios, you would rather, especially in a blockchain context, you would like to probably remove that trust. So another option that you have is to trust a third party, a centralized custodian, and you will give the custodian your assets, and then that custodian will enforce whatever rules and make sure that me as a trader, I'm not just stealing your money or anything like that. But that's still trusting
mhm,
someone, right? And we really want to get to zero trust. So the only option that you would have to do something with zero trust today is to limit me as a trader to one specific blockchain, right? And then you can create some sort of smart account or smart contract that will create the rules, enforce the access control, and
mhm,
then I won't be able to do anything that isn't authorized by the smart contract. But then I'm limited to one
mhm,
specific network, right? If I'm a really good trader, I probably want to do a lot
100%.
of things in a lot of different places, maybe even go off chain, on chain, different chains, right? Like I don't want to be restricted, and then my performance won't be as well. So you don't really have a solution today in order to do that. And what we created is infrastructure. This is, obviously just one way to use this infrastructure, but I think it's a good way to explain and then also connect it to AI agents. Infrastructure for zero trust, decentralized access control. And what we did is we created a new primitive on the blockchain. We call it a D wallet. So you can think like you have the apps,
Mhm,
you now
mhm.
have a D wallet. And a D wallet, although it sounds like a wallet app, it's not a wallet app. It's more of a on-chain primitive that can be used by builders, by devs. Maybe we can share the screen now. And
Oh yes, I think that's actually the idea. I like when people are bringing up like, visualization of things
awesome.
that you are.
So what we did is we created a new algorithm, a new cryptographic scheme. It's called 2PC MPC. And what it allows to have an on chain account that is managed by a two-party computation. So there's a user share and a network share. And the network share is operated by MPC by two-thirds of a massively decentralized network. So what we actually get is we get a programmable account that has zero trust assumptions. So the zero trust comes from the user share. If I have the user share, I know that no one can generate a signature for this D wallet for this account without me, right? So I have these guarantees. But then we have the network share, and the network share can enforce the logic of a smart contract. So that logic is enforced by a massively decentralized network and two-third consensus, just like any other network. And now you can have both the best of both worlds. You can have both zero trust, but also have logic enforced. And that can be enforced on any network because what you get at the end of this process is a signature. So you can sign a signature for
Mm,
Ethereum, for Bitcoin, for Solana, for any network that you would like, but you won't be able to sign
mhm,
it unless there's the user share, so the zero trust, and you have the network share that enforces the logic. So this is kind of the
mm,
basic primitive we created, the D wallet, and it can be implemented on smart contracts to do a lot of different things, right? So people implement them to do multi-chain DeFi. People implement them to have Bitcoin programmability because now you can enforce, logic on top of Bitcoin. People use it
mhm,
um, for custody, for gaming. There are a lot of different use cases, but I think AI agents is a super exciting use case, and
mm,
the basic premise here is, if we go back to the example of um, me wanting to you wanting me to trade for you,
mhm,
then
mhm,
what would happen here is you would give me just the user share, so I don't have full access to your account, and the network
mhm,
share will enforce the logic of what I can and can't sign. So now you don't have to trust
mm,
me, and you have a completely decentralized network that enforces the logic instead of a centralized custodian or something like that. AI agent, you can think
Okay.
about it exactly the same way, right? Today, AI agents, they
Mm-hmm.
run mostly off chain. I think it's a while until we have full on AI agents running on chain. But even if they did run on
Yes.
chain, they would still be constrained to the chain they're on. So if you want an AI agent to perform on your behalf on multiple networks, you would need to either give them full access, full control, or trust some sort of centralized third party to manage that control. And here, what you're able to do,
Yeah. You
yeah,
don't want.
here, what
Yeah.
you're able to do is you're able to take this user share to give it to an AI agent.
Mm-hmm.
That AI agent won't
Mm-hmm.
be able to generate a signature by itself. It will have to have the approval from the network share. And then that network share will listen to the smart contract that you defined. What are the rules, right? What can the AI agent do? What can't it do?
Mm-hmm.
And this is essentially the basic infrastructure we created in order to solve this big problem for AI agents.
This is very interesting. Like, do you want to walk us a little bit through kind of like the key technical decision when kind of like building this architecture? Like, I assume it was not kind of like straightforward. Then boom, that's done, right? Like, how kind of like was the building
So
journey?
when we started our process, we looked at the existing tech, right? It was almost 3 years ago, and we you obviously want to create as few things as possible from scratch, right? If you have things that already exist and are useful, then you want to use them as much
Mhm.
as you can. So we looked at everything that existed, and we found that there are four major issues that prevent us from creating this infrastructure and making it usable. So the first issue was speed. In order
Mm.
to create these MPC signatures, and even more than that, having it in like a decentralized network and all of that, it with the previous state of the art, it could take you seconds, minutes, sometimes even days or
Mhm.
months, right? It really depends on some of the parameters, but
Right.
definitely not
Yeah.
nothing that is usable, right? We wanted something that was sub-second. Like that is kind of the user experience and the performance that you're aiming for if you want to create very robust infrastructure. So that was the first big problem. The second big problem was scalability, so throughput. We looked at existing things and we saw that we could maybe get to like between 1 and 10 signatures per second, which it's nice,
Mhm.
but you can't build a robust infrastructure and expect the whole world to run on this type of
Sure.
infra. So that was another big problem. The third big problem was decentralization. All of the
Mhm.
existing solutions back then were very, very limited. I think the
Mhm.
kind of maximum number of parties that we have with like ECTSA signatures is maybe around 20 something, which is far from being decentralized,
Mhm.
and they have very low performance. So for better performance, people usually have less than 10 parties, which is barely even distributed. So that we wanted
Mhm.
to have minimum of 100, but we wanted to actually scale to hundreds and thousands if possible. So that was another big problem, and maybe the biggest problem. All of these are very big problems, but the biggest problem was the zero trust aspect. What happens with all of these MPC networks is you
Mhm.
lose zero trust because the user is not part of the decision making. So what happens is you take the key, you break it up between a bunch of different nodes, and then those nodes need to agree on signing a transaction. But then those nodes can collude or they can be compromised and they can steal the assets. The user needs to trust, and this is
Mm.
something that for us was unacceptable. We were absolutely certain that the user shouldn't need to trust anyone. That's the most fundamental assumption of blockchain.
Mhm.
So these are
Of
like
course.
four big problems that we needed to solve. And it took us 2 years of research with, as you said, some of really the brightest and most amazing
Mhm.
cryptographers in the world. And we eventually came up with 2PC MPC, which is a new
Mhm.
scheme, a new algorithm that solves all of these problems.
Nice.
So it can scale to um, hundreds, even thousands of parties as part of the algorithm.
Mhm.
It can achieve
Yeah.
sub-second signatures. It can scale to thousands, even tens of thousands of signatures per second. And most importantly, it has this very unique structure of 2PC MPC. That's where its names comes from. It's a two-party computation between the user and the network, and then the network has a nested
Nice.
MPC, which means that the user is
Yes.
always required, and that's why the user doesn't need to trust anyone.
Huh. That's very interesting. So there is, yeah, I actually like you remind me the trilemma, decentralization, decentralization, scalability, kind of like, and that was super interesting because the fact that you're not, yeah, you're basically like proofing yourself, everything is also giving a lot of like value prop to both the developers and the user using the tech. And also the AI agent, because one things I'm asking myself is that how you define frameworks and standards from agent to speak with the other agent, right? Because
Yeah,
right now we build software from human. Yeah.
yeah, I totally agree, and I think that one of the problems that you have with these, complex mechanisms is that if you don't have control over your assets, right? If you don't have control, then this AI agent can take the assets and then moves it to that, and then it ends up somewhere where you didn't
Yes.
even know that it will go to, and you have zero control and no way to prevent that from
Agree.
happening. So
But
we just
yeah,
saw,
yeah.
there was this
So
interesting experiment where someone launched an AI agent where he said
I saw it got
their
dropped,
only
right?
goal was
No.
to never send the assets out of that wallet, and
Yeah.
he had a challenge on Twitter of who can convince the AI agent to send them their money, and the pot went bigger. Like every person
Crazy.
who tried to do a prompt to send
Yeah.
asset had to
Yeah.
add more to the pot, and eventually someone was
No
able
way.
to make the AI agent send them all their money, even though their only direction was never ever send this money out to anyone.
Crazy.
So I think,
Crazy. But actually,
yeah, this is a
yeah,
good way
yeah.
of kind of thinking about how these AI agents would be exploited by, bad actors, and then you have these NPC
Mm-hmm.
guardrails for these AI agents
Mm-hmm.
that even if they're exploited, even if something happens, right? This is something that the NPC will just not sign, and now the AI agent won't be able to
It's
do
very
that.
cool. Yeah, you're kind of like you're kind of like speaking about some extra similar to the MEV protection, so kind of like agent protection. That actually super interesting. And uh and actually you remind me something that was actually like probably a problem like yeah, I remember it was not really an hack, was actually this guy dropping something. I think this is the one that you speak about, like 50K was basically stolen from the agent from another agent, convincing him. It was actually quite crazy. And actually speaking about the coordination, because this is also a reason why kind of like Modder exists, like all building this kind of like open registry for social graph for agents. Uh, how you actually think? How should kind of we think about kind of agent coordination then today?
I mean, that's a good question. I don't know if I have like the answer specifically for that. I think that what we're focusing is more the on the access control angle, right? So essentially, whenever you have this, and we will have more and more complex relationships between like different AI agents. What is really really important in these, and we come from cybersecurity, right? This is our background. What's really really
Yeah.
important is that we have very very robust and clear access control mechanisms, because we want to have like
Hmm.
the
Hmm.
most sophisticated and the most effective and efficient AI agents, but we also know that when things become complicated and hard to track, if you don't have very very strong access control mechanisms, then you might get to undesirable results. So I think this is kind of what we're focusing on, and I'm sure there are a lot of very smart people that are working on making sure that these, the coordination and the way that we map out these
Hmm.
relationships, all of that is done, at the highest level. We're kind of yeah, we can call it like a guardrail, or like a level,
That's
yeah,
very
like
cool.
a lower level beneath that, where we make sure that we have these red flags. This can't happen, this can happen, and
Yes.
nothing happens without this approval.
That's actually very cool. Yeah, I think it's basically an approval mechanism that is kind of like on a more base structure. Like, what are kind of like other things that you think right now around the technology side on agents are kind of either underappreciated or you see gaps? Because I think this is a big gap on kind of on the define mechanism, right? But I think maybe there is also other things.
So I think one of the main things that people will need to tackle is probably privacy. When
Mm,
when you interact with AI agents and AI agents interact with each other, they're like, some of these models are want to keep themselves private. People want to keep their input private, right? A lot of things around privacy, especially when we're talking about blockchain, can be
Mhm.
challenging. And I know there are a lot of teams that are working on privacy. Some of it is with like hardware, right? Things like TEEs. But then you have people that are working on cryptographic privacy, which I really think that's the future, using things like ZK and FHE and MPC in order to create privacy. So I think privacy is going to be a big, big thing. Right now, a lot of AI agents are like POCs, right? It's people are playing around with things, creating these like very cool things. But when you want to bring like real world activity to use AI agents,
Mhm.
a lot of people, institutions would want to make sure that is private, right? That people can't like reverse
Agree.
engineer their business strategies or activities. So I think privacy is a big, big thing that is probably kind of the next iteration of infrastructure for AI agents. um, and yeah, I think like, yeah, cybersecurity and privacy, so we're like more on the cybersecurity
Those
side,
are
and
big.
yeah, I think
Yeah.
those are the main big
Yeah.
things.
I mean, it's very interesting because, speaking about privacy, I think, we will have very verticalized agents, but the question is also how you're training those agents, right? I mean, right now we are not really doing open source training apart some projects out there, like, I don't know, like Nilion or something. And I think also like, um, secure training. I don't know how to call it, like some privacy preserving kind of LLM trainings of those agents will be super important. But yeah, I think there is a lot of kind of like gaps. I think what you're saying on the security side, on the privacy side, I didn't see much like on the ZK side, kind of like ZK implementation on the agent side. I think it's very early. Yeah.
Yeah, I think also it's just ZK is probably, for most use cases around AI agents, is a bit less appealing because you do want to work on a shared state.
Mm,
So you would need something that is like
correct.
confidential compute instead of like client side
Oh, yeah.
proving, right? Like it's just
Yeah.
less relevant specifically for most use cases. But I am pretty sure there are use cases where you would want, for example, to prove that an AI agent did something without, actually showing what
Mm,
they did.
yeah.
So then ZK.
I mean, yeah, you could also solve this with like public registry attestation with having like a ZK kind of like state on something like EAS or Verax or something like that. That would be actually like an option. Yeah, those are great a great input. I mean, also the reason why I think so many, I mean, agent you mentioned already, like they will be always being around. But the cool things to deploy your agent on a Web3 rail is that you have these shared states.
Exactly.
So I think like a lot of people coming from the Web3 world on let's say, and I see a lot of like those folks. We just spoke with the agent called Solange, and they're literally all people like all PhDs coming from Web3, but the benefit of having a Web3 rail infrastructure is that actually this DevRel agent could actually finally have a fully open source data, DeFi data. So you have literally like a paradigm that is opening up that maybe before was not even possible. So that's super exciting. Yeah.
Absolutely. Um, yeah,
No,
and
no.
I
Mhm.
just want to add that so Ika is available on the Sui network. So
Mhm.
people can build smart contracts on Sui network in order to control on-chain and off-chain activities, right? So you can use it also for AI agents, no matter where they operate. There's also
Mhm.
another project that we're working with on Sui network called Atoma Network that are working on
Mhm.
platform and infrastructure for AI agents, and they're very excited about incorporating these MPC guardrails in
Mhm.
their platform as well. So yeah, I definitely, if anyone is interested in this type of infrastructure, come over to our Discord, our website, our Twitter. We're going to launch our mainnet very soon, but testnet is already live, so you can start playing around with the tech
Nice.
and build and see how it works. And yeah, I
Nice.
think I think we're going to be a very important invisible structure infrastructure, right? But
Oh yeah.
very important and fundamental.
But
Yeah.
you need that. Yeah, that's why it's super exciting. And like I mean, speak about kind of like verticals that you see right now on testnet, like being deployed on testnet. Apart like agents, what kind of vertical do you see? Like you see more like DeFi, DADs.
So
What's
I
going on?
think a lot of people are focusing on Bitcoin, because with Ika
Mm,
you can
yeah.
interact with native BTC, because
Mhm.
you kind of make the account programmable instead of the asset. So you don't need to bridge BTC and create a wrapped version. You can just apply your logic
Mm,
on native BTC. So you can, for example, take a loan against native BTC without ever bridging or wrapping your Bitcoin. So there's all these like very interesting Bitcoin use cases that I think it's just a huge market and people are very excited about it. We are also seeing a lot of custody solutions. So yeah,
custody,
so
yeah.
there are people who are
Hmm.
competing with like Fireblocks or Gnosis Safe and are building this very
Yeah,
decentralized but multi-chain infrastructure where one of the projects, by the way, Aeon, they're building like a custody solution, and their one of their main use cases is AI agents that will connect to their custody infrastructure,
mm.
and you would define these rules
Ah,
on your custody platform. So you would hold all of your assets in their custody, which is actually a smart contract. And then you would be able to say, okay, these are my rules. And then an AI agent will be able to connect and only have the access according to those rules and nothing else. So kind of
nice.
a nice
That's
tie all
very
of it
cool.
together.
Actually, I see that a lot because especially on institutional kind of solution, you always need some kind of like extra security layer. I remember when people, even enterprise taking, people say, "Hey, is this actually like, are you running like, front running? Like, is there some kind of extra of the extra?" I think providing this will help reassure. But the cool thing is that you're not just reassuring with a third party signature, right? You're assuring actually based on tech. And I think cryptography here wins
Yeah, I
all
agree.
the time.
And this is
Yeah.
also why it was important for us to have a massively decentralized network. So we're going to launch mainnet with around
Hmm.
100 validators, but we're just going to grow from there.
Yeah.
And that
Yeah.
means that you'll have a really decentralized network and not a single source, a single point of failure.
That's very cool. I think actually, and it's actually a big shout out to you guys because launching mainnet with Android validators is really is a strong actually like
Yeah.
milestones. I think it means also like people actually want to be part of a fully kind of decentralized
And
ecosystem.
more than that, like the largest MPC network today is around, I think, 24. Like that's the largest, and they
Oof,
completely
nice.
like broke the record, right? I think it's ICP, and they
Oof.
broke the record with
Yeah.
like 24 parties, and their throughput is like one signature per second, right? We're going to scale to 10,000 signatures per
Nice.
second. So
Nice. That's interesting. Yeah. Yeah. And like on the user, I understand on the user side, on the infrastructure layer side, I understand the value prop. Like how kind of like developers and builder are onboarded on
yeah,
ICA right
so
now.
actually we are only low level infra and we're only targeting builders. So actually the
Mhm.
end user will only interact with Ika through some sort of product, some sort of smart contract that will I mean you can
Mhm.
interact directly, but it's not a user friendly product. So we
Mhm.
essentially enable developers to use this D-wallet primitive on their smart contract and
Mhm.
then build their product around it. So you can build, for example, infrastructure for DeFi agents. So a smart contract where a user can define their rules, and then the AI agents connect to that smart contract, gets the part of the key. We can like encrypt the user share to the DeFi agent. So on encrypt it on chain. So everything can happen on chain, and the DeFi agent will get access, but controlled access with MPC guardrails.
Nice, nice. Actually, yeah, super useful. So I'm assuming that you guys have also like specific tutorials, onboarding tutorials in the docs, and people can actually
Yeah,
check
I
it
mean,
out.
we are
Okay,
of
no,
course
sounds
in
good.
an early stage and just launching, and so we do have documentation. It's
Yeah.
not, the most mature and robust documentation, but we're always working to add more examples, and people are now launching their products too. So people, other developers will be able to see some examples of how it's used. But yeah, in general, we're seeing a lot of very interesting use cases and very interesting implementations of this tech.
Nice. So you touch on the mainnet, Android validators, Android Plus validators. So what's next is coming on the cryptography side, like on the research
Actually,
side, that you can
There
share,
are there
obviously.
are
Yeah.
quite a few interesting things that we're going to do on the cryptography
Yeah.
side, but I can't share them quite yet. After we launch, we're going to
But we will see you in
yeah,
Denver,
actually yeah, definitely.
or nice,
And
nice.
we're after we launch mainnet, we'll announce our roadmap for Eka V2, which is going to bring some pretty amazing things. And we have some very strategic partners that are working with us on that. So a lot of the world of kind of interoperability and what you call things like chain abstraction or things like that. A lot of that is going to dramatically change with Ika V2. And yeah, I can't share a lot, but we'll talk in Denver, and I'll
Nice,
let you know.
nice. Nice. No, I'm excited. I'm actually excited also, like, to invite you for some kind of like part two that you actually show me, or even building this kind of like AI agent security side, right? And I think that's super exciting. Like, you guys are definitely like cooking on a very strong speed. Yeah.
Awesome. Yeah, for sure.
Awesome.
I'd love to come again after we go live and show you some real world examples. I think once this infra is live, it's going to be adopted very, very fast because it solves a very fundamental problem that all AI agents that operate on chain have today.
Nice, 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 nice. Sounds good. Awesome. So, David, thank you so much. I think we are really on time. I actually appreciate all the people that tune in. I see like almost 1,000 people here, and is a lot. And I actually like have a interesting comment. A lot of it is gonna change for IKV2, so we definitely like look forward for that. And thanks, favorite Sui. The fact that it's on Sui is actually very interesting, and we should definitely like speak also on that. I think it's
For
strong.
sure.
But yeah, awesome. I could stay here for 1 hour more, but let's close it up, David. If you have also link, feel free to send it over, and I think we will share it with the
Awesome. Thank you
community.
for
Awesome.
having
Thank
me.
you so much,
Appreciate
David.